Here I'd like to introduce the concept of logarithms. A logarithm on your calculator is most often noted as the button that says log. People for short will say log. So what is a log? A log is just another way of writing exponents. It's a way of taking that exponential value and turn it into like a linear concept. So I want to do a couple examples, try to walk you through the process and see if we can get you understanding how to use and operate with logs. So first off, let's look at the structure. The structure will say that you have a log and they'll put a value down here. So I'm going to call it B. Why? That's your base. And then you'll have an argument right here, which might be C, and it'll equal some other value, which I'll call A. That'll be the structure for a logarithm. The B is going to be your base. The A is going to be your power or your exponent. And C will be your end result. So it's kind of backwards. It's all over the place. This would be your, I call it the argument. If I could spell argument. And so really I'm just going to do a bunch of ideas here to show you how this is working. I could say a log base 2 of 3 is what? So when you look at this, you go log 2, 3, what? You're kind of going in this circular motion. 2 raised to the third would be, and that's what goes here, 8. So log base 2, 8 equals 3, meaning 2 to the third is equal to 8. And so I'm just kind of write it like this. I have a 2 raised to the third power is equal to 8. This is leading us to that, or vice versa. It goes either direction. So you can go either direction with that. And then let's give you a couple examples here. I'm going to go through different phases as I go through this. It takes a little while to understand what's going on. Once you get the gist of it though, it's not too bad. And this would be one of those ACT concepts that we want to put in place. So let's go ahead and call this example 1. I've got a problem that says log base 6 36 equals 2. And the instructions are saying, can you convert this into exponential form? So looking at this idea that I did above it, you could say 6 to the second power, or 6 squared, equals 36. 6 to the second power equals 36. We'll do another example like this. We'll call this example 2. It says log base 3 81 equals 4. To understand what this is saying, it's saying if your base is 3, 3 raised to the 4th power is equal to 81, which I agree. And then I got a third example of this. It says log 25, base 25, 5 equals 1/2. This is saying 25 raised to the 1/2 power is equal to 5. I don't know if you remember that or not, but if you raise something to a fraction like this, that fraction is actually read as like a square root or a cubed root or a fifth root. So if I said it was raised to the 1/5 power, that would be a fifth root. To the 1/2 power would be a square root. So it literally is saying the square root of 25 is 5. That's what that exponent fraction means. It's considered a root. And so that's our first part of this concept of logarithms. I'm not done yet. I'm going to keep rolling with this. We can go a couple different directions. So, as I was alluding to, on these first three examples, we can start with the log structure, with the log writing, and go to the exponential, or you can go from exponential and go into the logarithmic form. So this is our log form, this is exponential form. I'm simply going to start here and ask you to go backwards now. So let's do a couple of these. I've got 9 to the 1/2 power, to negative 1/2 power, is equal to 1 over 81. They want me to take this, and this is example 4, and they want me to convert that into a log. So you have to ask yourself, first, what is your base? Your base is 9. So you could say this is log base 9. What is the result? The result is 1 over 81. So you say 1 over 81 equals, what was the exponent? The exponent in this situation was negative 1/2. I wrote that kind of funky. That's not an exponent there. It's actually down. It's just a regular number right there. Do an example 5. Maybe they say 7 squared equals 49. So looking at this exponential form, can we turn it into a log? What is your base? The base is 7. So you could say log base 7. What is your result? Your answer was 49. So you put that right here. Equals, what was your exponent in this scenario? It was 2. So it's log base 7 of 49 equals 2. We'll go ahead and do a third example of this. Call this example 6. And I've got 1/3 squared equals 1/9. For this, you could say log, you ask yourself, what is the base? The base in this scenario is 1/3. So you say log base 1/3. Your result was 1/9 equals, what was the exponent? A 2. So there we've got 6 examples on understanding the concept and the workings of a logarithm. You've got this log, and right beneath it is a subscript. See, it's written beneath that on each one of these. I wrote that kind of small and downward. We call that a subscript. That's your base. Your answer or your argument comes immediately after it on the same line where you wrote the log, equals the exponent or the power. And that's the way each one of those worked. So it was 6 squared is 36. 3 to the 4th power is 81, and that's what you see over there. 25 to the 1/2, which is the same as saying square root of 25, is 5. And then for our last 3 examples, I can work from this side over. It's saying 1/3 squared is 1/9. 7 squared is 49. 9 raised to the negative 1/2 power is 1 over 81. That's not right. That should be 9 to the negative 2nd. Why does that say 1/2? That should be negative 2nd. I screwed up on that. That should say 9 to the negative 2nd is 81. And think about it this way. We've talked about traders. 9 squared, this would just be a 9 square as a denominator. So 9 to the negative 2nd is 1 over 9 squared, which is 1 over 81. 9 to the negative 2nd is 1 over 81. 9 to the negative 2nd is 1 over 81. So there we have 6 examples of how to use this structure, how to work a logarithm.